Hello everyone, hope you all are doing well. So today we are going to do topic 51 of paper 2, topic 51b, topic 51b of paper 2, that is remaining parts of respiration. So here we are going to discuss glycolysis. So the first topic of the second part of respiration is glycolysis. So what is glycolysis? It is stepwise degradation of glucose to pyruvic acid. Stepwise degradation of glucose to pyruvic acid. It is also known as EMP pathway. EMP pathway, that is Embden-Meyerhof Pranas, P for Pranas, Embden-Meyerhof Pranas pathway, common respiratory pathway or cytoplasmic respiration, or you can say common respiratory pathway or cytoplasmic respiration. Now we'll see the steps through which glycolysis takes place, through which glucose is converted into pyruvic acid. So first of all, glucose, it is converted into glucose 6-phosphate, and this takes place in presence of hexokinase. Here the enzyme is hexokinase. So I have discussed in very detail what enzymes are in previous lectures, so you must go and watch the lectures of enzymes. It is very important. And then this glucose 6-phosphate is converted into fructose 6-phosphate. Fructose 6-phosphate, and this happens in presence of isomerase. And here you must know that 1 ATP is converted into ADP. And then this fructose 6-phosphate is converted into fructose 1,6-diphosphate. Fructose 1,6-diphosphate. And here also ATP is converted into ADP. And here the enzyme that is used is phosphofructokinase. Let me write it, phosphofructokinase. F for fructo. This fructose comes from fructo. And then this fructose 1,6-diphosphate converts itself, here the reaction takes two turns. It converts itself into dihydroxyacetone phosphate, and here it converts itself into 3-phosphoglyceraldehyde, and these two can interchange itself. And then this again forms 1,3-diphosphoglyceric acid. 1,3-diphosphoglyceric acid. So here also enzymes are used. I will let you hear. Aldose is used. Aldose converts fructose 1,6-diphosphate to dihydroxyacetone phosphate, and 2-pi is used to convert this. And here from D-phosphoglyceraldehyde to dihydroxyacetone phosphate converted in presence of isomerase. I am giving these enzymes importance here because sometimes they ask reactions. Once they ask reactions, so you must know some important enzymes such as isomerase, hexokinase, aldose, etc. and here the enzyme phosphotriose is used. Phosphotriose, which converts dihydroxyacetone phosphate to 3-phosphoglyceraldehyde. So I hope you understand. Now moving on, from this 1,3-diphosphoglyceric acid, 3-phosphoglyceric acid is present. 3-phosphoglyceric acid is made, and here also there is 2 ADP is converted into 2 ATP, and here the enzyme that is used is phosphoglyceromutase. From phosphoglyceric it comes phosphoglycero, and it is mutase, and it converts 3-DGA into, that is 3-diphosphoglyceric acid, to 3-phosphoglyceric acid, and then this phosphoglyceric acid is converted into 2-phosphoglyceric acid, from 3 to 2-phosphoglyceric acid, and here the enzyme used is, here the enzyme used was phosphoglyceric kinase, and here the enzyme used is phosphoglyceric mutase. Sorry for the confusion. And then this 2-phosphoglyceric acid is converted into 2-phosphophenol pyruvic acid, 2-phosphophenol pyruvic acid. Okay, and here the enzyme that is used is enolase Mg++. Enolase in presence of Mg++, Mg+ ion. And then this 2-phosphophenol acid is converted into phosphophenol pyruvic acid is converted into pyruvic acid in presence of pyruvic acid kinase and presence of Mg++ and K+. This is how from glucose through long process converts into pyruvic acid, and it is very important. You must know the steps. So it is easy because their names are similar, so you can understand. So from here you can say that phosphoglyceric to 2-phosphoglyceric to 2-phosphophenolic acid. Here also you can say from glucose to fructose and to 3-diphosphoglyceric acid. So it can be remembered with good presence of mind. So this was the process of glycolysis. Hope you all understand this. Now what happens in glycolysis? So in glycolysis, 2 molecules of ATP. Here what happens? 2 molecules of ATP were used. You can see here in the first half of the reaction where we have converted ADP to where ATP was converted to ATP. I hope you understand. You can see in the reaction. You must be understanding from there. And 4 molecules of ATP are produced, and 4 molecules of ATP is produced. So the net gain is 2 ATP, that is 4 minus 2, that is 2 ATP. Also 2 NADPH2 is also produced, and each of its molecules gives 1 NADPH gives 3 ATP. So 2 into 3, it gives 6 ATP. So here another 6 ATP is formed. So this was the outcome from glycolysis. Now what is oxidative decarboxylation? Oxidative decarboxylation. So what happens? One glycolysis takes place in cells of cytoplasm. Once glycolysis takes place in cells of cytoplasm, it produces pyruvate, which continues on and into matrix of mitochondria. This pyruvate continues on to matrix of mitochondria. the Krebs cycle, and in the matrix of mitochondria, what happens? The Krebs cycle is the next step of cellular respiration. Then takes place Krebs cycle in mitochondria, that is next step of cellular respiration. We have discussed Krebs cycle in detail in previous lecture. You must see it. It is very important. But before Krebs cycle takes place, we need another step called oxidative carboxylation. But before Krebs cycle takes place, we need another step of oxidative carboxylation, which has to convert pyruvate into acetyl CeO, which has to convert pyruvate into acetyl CEO. So we have used acetyl CEO and pyruvate in Krebs cycle. So how this pyruvate is converted to acetyl CO is called oxidative carboxylation, and we will discuss the steps of oxidative carboxylation now. Steps. Carboxyl group is removed HCO2. Carboxyl group is removed as, this is decarboxylation part, hence its name is decarboxylation, because it is removed HCO2. This is decarboxylation part. Then this is first step. Now second step. Then remaining 2 carbon part is oxidized by, remaining 2 carbon part is oxidized by NAD plus. The NAD plus gains 2 hydrogen and remain, and this NAD plus gains 2 hydrogen and remain 2 carbon compound becomes an acetic acid, and remaining 2 carbon compound becomes acetic acid. Then a coenzyme A attaches to acetic part forming, then coenzyme A, that is CoA, attaches to acetic acid, part forming acetyl, and this then forms acetyl. This is the molecule needed to continue Krebs cycles, and this molecule is then needed to acetyl CoA is needed to continue Krebs cycle, because in Krebs cycle first of all pyruvic acid is converted to acetyl CoA, and then the next steps continued. So what happens here? Pyruvate plus CoA, coenzyme A, plus NAD plus gives out acetyl CoA plus CO2 plus NaDH plus H plus. So what happens in respiration? First of all, glycolysis takes place, then this carboxylic oxidation or deoxidation takes place, and then Krebs cycle takes place. So this is the full process of, and we have discussed all the 3 now. I hope you understand all the 3. So that's all for today. We have completed respiration. For any queries, do comment. If you like it, please press the like button. Do share and subscribe. Keep making notes. That's all for today. Have a nice day. Thank you.